In this video, we are going to look at key features of the graph of sine of theta. So we talked about in class today how the graph of sine of theta is related to sine's values around the unit circle. And I just wanted to go back over that really quickly in case anyone missed it or for my at-home people who didn't get to see it. So you remember from what we talked about before that the sine of a radian angle is related to its y-coordinate. So if you look at the y-coordinates of these 4 points, I'm going to start with this one. The y-coordinate of this point is 0. And then I move up here. The y-coordinate of this point is 1 because I went up 1. Right here, the y-coordinate of this point back to 0. And the y-coordinate of this point is -1 because I went down 1. Okay, now I'm going to put those values on my graph. So let's see. When the radian measure is 0, my coordinate there is 0. So my y value is 0 as well. I'm going to put that right there. At pi over 2, you can see that I went up to 1. At pi, I'm back down at 0 again because I went up and down none. At 3 pi over 2, I'm at -1, which is down here. And then at 2 pi, I'm back around to 0. So if I connect those dots, that will give me one portion of the sine graph. So it starts at 0, it goes up, it goes down, and it goes back up again. So one thing I want you to notice is that this graph could potentially be cut into 4 pieces. From this dot to this dot is one piece, this point to this point, and then right here, and again right here. And notice how that corresponds with the quadrant that I was in on the unit circle. So right here is the first quadrant, and you can see sine is positive and sine is moving from 0 to 1. In the second quadrant, that's right here, again sine is positive. Oops, I should put a Roman numeral. Again, sine is positive, but now it's moving down because it's going from 1 back down to 0. Right here is the third quadrant. In the third quadrant, sine is negative, and it's moving towards -1 right here. And then in the fourth quadrant right here, sine is still negative, but it's heading back upwards towards 0. And you guys remember we talked about angles that are coterminal. They end in the same place, and you just go around and around the circle however many times you want. And truthfully, you could take this shape, this sine curve shape right here, and I could go around the circle again, and I could just go up and back down and keep going in that same manner. It just repeats itself over and over and over again. Okay, let's take that idea and let's look at the negative part of it, because if it repeats itself over and over again positive, it ought to repeat itself over and over again negative as well. So again, I'm going to start right here at 0. Only this time I'm going to move around the unit circle in a negative manner. I'm going to go clockwise. So I'm starting right here at 0. I'm going to move down to -1, back up to 0, up to 1, looking again at those y coordinates, just like we did before, only this time because it's negative, my radian measure has changed a little bit. Okay, so let's put some dots on there where we just put those values. At 0, I'm at 0. Then at -pi over 2, you guys can see negative. I'm going this way down into the fourth quadrant. So I'm going to be at -1. And then at -pi, I'm back up to 0. -3 pi over 2, that's up here, so I'm back to 1. And then -2 pi over here, back down to the axis. So just like before, if I connect those points, what I'm going to get is another rotation of the sine curve. And you can see that this one looks exactly like that one. It's just that this one is in the negative part. So this is quadrant 4, 3, 2, and 1. I'm moving backwards on the unit circle. Okay, so now let's take those ideas and look at some key features. So I asked Desmos to graph this one for me so that I could have a nice looking curve. Let's look at the domain. Okay, remember Desmos, no other technology can put those arrows on there. I put them on there for us to look at. This one tells me that the graph is going on and on forever left. This one tells me the graph is going on and on forever right. And remember we said it's just going to keep going in this same shape over and over and over again to the right, over and over and over again to the left. So at no point as I'm drawing do I have to pick up my pen, right? I can draw the whole thing without having to make any gaps or any stops. So that tells me that the domain is from negative infinity to positive infinity, or you remember our symbol. I can use the all real numbers symbol on that if I want to. Now, how about range? Look at what's happening at range. No matter how many times I go round and round and round the unicircle, I'm never going to be able to get past +1 or past -1. I'm in between +1 and -1 over and over and over again. So remember we said range is bottom to top. Always start with the smallest number and go up to the biggest. So the smallest value that sine of theta can have is -1, and -1 is included because you guys can see I've got a dot right there on -1, so it's included, and it goes up to +1. And again, +1 is included. I've got a dot right there where it's going to be included. So the domain is negative infinity to positive infinity, and the range is -1 to 1. Now, when we get ready to do some translations in a couple of days, that's going to change, but just the general sine curve, always the domain is this, and always the range is that. Okay, so let's look at some new vocabulary words that we have not seen before. The first one of those is period. So this graph is called a periodic curve because it repeats itself over and over and over. It has that same cycle over and over. And you can see that the basic shape of the sine curve is right here. And it starts that shape here at 0, and it completes right here at 2 pi. So one cycle of the curve takes 2 pi radians to complete. So some vocabulary you need to write down. Any one full pattern in a repeating graph is called a cycle. So as I go across the sine curve like that, that's a cycle. And you can see I have another one right here. You can see that I have another one right here. This time I went out, I zoomed out on Desmos so I could see a little bit more. And you can see I have 1, 2, 3, 4 repetitions of the sine curve. Every one of those repetitions is called a cycle. Now, the length of the interval over which the cycle occurs is called the period. So it starts here at 0, it completes its cycle at 2 pi, so the length from here to here is 2 pi radians, so therefore that is its period. Now, what if I measured this one over here? Do you remember when we did that one on our graph earlier? We had this value was -2 pi. So if I were to look at a different cycle, let's suppose this one that's going right here, I'll color it in a different color so y'all can see it, right? If I look at that cycle, the distance from here to here is still 2 pi. 0 minus -2 pi is 2 pi. So my distance that it takes to complete one revolution, one complete trip around the circle is 2 pi. So it doesn't matter which one of them I look at, the period is always going to be 2 pi. And the reason why is because it takes 2 pi radians for the graph to complete one full cycle. Okay, another vocabulary word we need to have is the word amplitude. Amplitude is the distance between the midline of the graph, which in this case is the x-axis, and the top or the bottom. So I can measure from the midline up to the very top, or I can measure from the midline down to the very bottom. Either one of those is called an amplitude. It doesn't matter which one you use, both of those are called amplitude. So the amplitude of sine of theta is 1 because the distance from the x-axis to the top is 1. The distance from the x-axis to the bottom is also 1, right? The distance between 0 and -1 is a positive 1. Distance is a positive measurement. So because this distance is 1 and also this distance is 1, the amplitude in this case is 1. The x-axis here is our midline. So in several days, we're going to start doing translations, we're going to do dilations, and we're going to change some of these things. We're going to be able to take the sine curve and we're going to stretch it up and down. We're going to take the sine curve and we're going to move it onto a different midline. But this is true for a general sine curve. For the one that just comes straight off the unit circle, the one that's just y equals sine of theta has an amplitude of 1 and a period of 2 pi.